Hello everyone, this is Ali Reza. In this episode, we will start our reflection utils, but it will become more rich as we go forward in the whole project. But for time being, I want to have some utils here, and they will all be responsible on finding types. So before going forward, I noticed something on my utility. I'm making this guy's name utility. I don't like this naming, so I will just hit F2 and make it utils. And because I'm renaming the class name here, it will rename it here, and it will rename everything inside the solution thanks to ReSharper. So okay, and yeah, I know that I had this problem. I will come to this guy later. And that's that. So inside utility on the common project, I will add a class called reflection utils. Now, reflection utils is a static class, of course. If Visual Studio won't freeze on me. So I will have a public static list inside system.collections of string, and I will name that assembly names. Okay, and let's make it a public getter private setter. Then we will have a public static, not string, static dictionary of assembly in system.reflection, comma, list of string, and I will call it namespace cache that has a get and a private set. Okay? Then I will have a public static assembly array called assemblies. And again, it's a get with private set. After that, I will have a constructor to say that, well, I forgot one of them. And that is a public static dictionary of string, comma, type. If I find it. Type in system, and I call it type cache. Again, get private set. Boom. So I will say type cache equals to new that assembly names equals to new that, and namespace cache equals to new that. Okay, and assemblies equals to get all assemblies. I don't have this method yet. There. Now I will have a public static that returns a type, and I will call it get type by qualified name. Okay, and I will send in a string as name. I will have another public static string that says get qualified name, and I will send in a string as name. And by the way, here I will have another string namespace with capital S. If you want to use something with lower s, you need to have an @ sign in front, and I will set it to empty string, okay, as default. Then I will have public static that returns a type, and I will call it getType, and I will send in a string as name and a string as namespace. And again, the namespace is defaulted to empty. Then I will have a public static that returns a list of a string, and I will call it get namespaces, and I will send in an assembly. So I will get the namespaces inside an assembly. I will come back. Okay, sorry for interruption. And finally, I will have a public static that returns an assembly array, and its name is get all assemblies. So that there. Now, where to start from? Well, get all assemblies is really simple. All we say is return from app domain. App domain is the whole project, okay? Your whole Unity project. Go into the app domain, get the current domain and assemblies, and return it for me. So it says that, hey, inside Unity, go to the current Unity project, see every assembly that is running inside this project, return them for me. Okay? Get current namespace. We say a list of a string, and we call it names. Then we say if namespace cache dot try get value, the assembly that's sent in, comma, out to names. So if we could find this assembly inside our cache, then we don't need to do any reflection, and we just get its names as namespaces and return it, okay? So do that for me right now. So don't do any more reflections, just return the names. Otherwise, if we didn't have this assembly cached right now, then we say names equals to assembly dot get types. And if you look at its definition, it says get the types defined in this assembly. Remember, assemblies, I think I'm correct. If I'm wrong, Nelson can fix me there. But each assembly has one-to-one relationship with your projects. So for example, this is one assembly, this is the second assembly, this is the third assembly, this is the fourth assembly. In each one of these assemblies, we have some namespaces, okay, and some types in there. So first, we want to get types because we don't have access to the namespaces directly, but from each one of these types, now we use link, we say select a delegate goes into the condition or running of get the namespace from that delegate. Remember that in previous episode I said the type is the heart of every reflection call. Now here it is. From each type I get its namespace. Okay? Then I use distinct, and you will see that it says well, no description, but it returns an enumerable of source. Okay? So we say distinct, and finally we say to list. Okay? And we got our names. Now we say if not namespace cache dot contains key for the assembly, then we say namespace cache dot add assembly as the key, and the names of namespaces as the values, and we return the name. Okay? Else, I'm not sure, this is not in my notes, but let's say namespace of the assembly dot add the names, and it won't work. Sorry, add range, I think. Yeah, this would work. Okay, but I need to check. Well, forget about this part. Bam. Because I had to check if each name is not there, then do that. And you see that this private set is redundant now. Okay? So, get type. We say if assemblies equals to null, or not assemblies.any. So if our assemblies are empty, we say assemblies equals to get all assemblies. Okay? That. After that, we say list of types equals to new list of type. And yeah, let's do it in this way. So for each inside assemblies, we call it ASM for assembly. We say types dot add range ASM dot get types. So we get the types inside each assembly inside the project. Okay? Then we say var type found equals to types dot first or default. We send in the delegate into the condition that type dot assembly qualified name first is not null, and type dot assembly qualified name that contains the name that we sent in, and type dot assembly qualified name that contains the namespace that we sent in. Now, if I want to show you what an assembly qualified name is, I can, but it means that I need to write a script somewhere, and I will do it. No, I won't do it, but you can simply say, you know, something like type of, like this, debug.log type of reflection utils, for example, or this dot, and it won't work, type of something, for example, FA, okay, dot assembly qualified name. Put it anywhere you want, in any script you want. Even I can put it inside my menus. Let's see, where is that menu? My menu thingy. And I will say, you know, a menu item inside buzz, and I will call it test. Then I will say public static void test menu. That I will do it here like this. Okay, and what are you yelling at? I forgot this. And yeah, we need Unity Engine debug and import FA. Okay, so whenever I go back to Unity this time, you will see this test, and I will be able to show you these guys. So let's do debug.log type of FA itself. So I will send in the type, and then I can say type of FA dot namespace. Then I can say dot assembly. Then I can say full name. Then I will say dot, and I think I have a name. Then something like dot attributes, why not? Dot base type if it had. Dot, what was that? Declaring method, declaring type, GUID, because you remember each object in .NET has its own GUID. And yeah, there are tons of things. Is abstract, is ANSI class, has element type, is array, is auto class, blah, blah, blah. Is class, is enum, is generic parameter, is generic type. And yeah, you see when you get the type, you have all these stuff. So for example, reflected type, other things, for example, if I find get events and get element type, get default members, get constructors, find members, and get interfaces, get members, get methods, get properties. All of these will work, invoke a member. Yeah, basically these will be enough. So type of FA, then namespace of FA, assembly of FA, full name of FA, name of FA, attributes of FA, base type of FA, and finally the most important one, qualified name of FA. Okay, this will come later. But now, where was I? Yeah, get type. So after I get the type that has this name and this namespace, I want to check if type found, and look at me, my typo. First does not equal to null. If we found anything with this criteria and not a string that is null or empty, the type found dot assembly qualified name, then we want to check if not type cache that contains key for the type found dot assembly qualified name. After all of this, we want to say type cache dot add the type found dot assembly qualified name as a key and the type we found as the value. And at the end, we return the type found. We don't care if we didn't found anything. Type found, where are you? There. We don't care if it's null or not. If we didn't find anything, we return the null. Get qualified name. We say string qualified name equals to empty string. And at the end, we return that. In between, we say if Again, assemblies equals to null, or not assemblies.any, so we don't have collected assemblies by now. We say assemblies equals to get all assemblies. After that, we say a list of type, and we say types equal to new list of type. After that, for each inside our assemblies var ASM, we say types.add range of ASM.getTypes. Then we say for each inside types var type, we say if not string dot is null or empty, the type dot assembly qualified name, and the type dot assembly qualified name that contains name, and the type dot assembly qualified name that contains the namespace that we sent in. We do two things. We say first qualified name equals to type dot assembly qualified name, and we break out of the loop, and at the end we return the qualified name. Now, all of this had been here just to get this. Well, this is a good way. I like it and I use it a lot, but this is also a good way of getting a type. When we have the assembly qualified name, for example, in this case that I'm using type.fa, I don't need to, loop through all the assemblies, collect all the types. I have the qualified name right off the bat. So I send in the or qualified name and get a type. Although in this case it would be stupid because type of FA is returning a type. As you look, if I move my mouse on type of, it won't show. But rest assured, if I say var t equals to type of FA, you would see that t now being a system.type. Okay? So type of will return a type, and honestly it will be stupid to send in type of FA assembly qualified name then get its type back. But sometimes I may have an assembly qualified name without getting access to the same class. So it would be useful to have this method around. Although, as I said, I never found myself using this type. Most of the time I'm using this type. But this is a good way. So let's say try. First we say type equals to nothing. Then we say type cache dot try get value the name out to type. If reference equals type with null, means that we didn't find any type in our cache. We say if assemblies equals to null, or assemblies dot any is not the case, then we say assemblies equals to get all assemblies, and I think I forgot something. No, that will work. Okay? After that we say for each inside assemblies dot where ASM goes into the condition of not assemblies dot contains ASM dot full name var ASM, What did I do wrong? Oh, sorry, assembly names. There we go. Assembly names. So I'm using the same delegate name in two places. Don't get confused. This will be happened once, and then it will happen. So, for example, I could say assembly, and make this assembly to get rid of the confusion. So what I'm doing here is I'm using lambda link and then for each. What I'm doing that I'm checking that first I collect all the assemblies that I don't have their full name inside this cache. Okay? Then inside that collection, I will loop through them to add the names into the cache. So we say assembly assembly names dot add asm dot full name. After this, we say for each inside our assembly names var assembly name, we say type equals to type dot get type name comma, put a comma inside in name, sorry, plus a comma plus assembly name. If not, reference equals the type with null, then break. After that, we say if reference equals type with null, means that our first method of finding the type by the name, by the qualified name, is failed. So we need to do tweaking here. So if it falls, then we have to do a more advanced thing and say for each inside assembly names var assembly name, we say string temp equals to assembly name dot substring of 0 comma assembly names of index assembly names dot index of comma string comparison comparison dot ordinal. Okay, and I missed something. Assembly names but substring, oh well, this is assembly name, lower assembly name. There we go. Okay, and after that we say type equals to type dot get type the temp plus a dot plus name plus a comma plus the assembly name. Okay, if not, reference equals the type and null, break out of the loop. At the end of here, we tried everything we could do. If we can't find our assemblies like this, the type like this, then, well, that type is not sitting in the project. So we say if reference equals the type with null, simply return null. Okay? But if we found it, we say type cache dot add, because we try to get the reference out of the cache before, so we know that it's not in the cache. We want to add it. So we say type cache.add the name, the fully qualified name, with this type. And at the end of this if statement, we simply return the type. Either now, if we found it here, we will jump down here. If we didn't find, we will try to aggressively find the type. If we hit here inside the cache, we get the exception, and we say debug.log error reflection utils get, come on, type by qualified name, so that I know which method is yelling at me. Can't find the type with the exception. And I will put 0 here. So I need to say string.format and comma the name we sent in. Okay? And I will add the exception here, plus E. And then return null. So that's our reflection utils. And you may notice that it says, hey, make them private. It's not being used. I will say, shut up, ReSharper. And more. Oh yeah, this one. Merge sequence checks. It will work if you are not working with Unity. It won't work in Unity. So make it shut up. And this guy says, make it private. No, I want to be accessible outside. And now you see that these things are redundant, the private sets. So coming back to our one error, I will comment this line for time being and build my solution. I won't have any errors. Cool. Now I will run Unity. And I will have this test. Now look at the console here down. If I hit the test, we get some entries. The first entry says type of FA is buzz.common.fa. This is when I use the type of. Then we say namespace as FA is buzz.common. Assembly of FA is common, comma, version equals this, culture equals this, public key token is null. Full name of FA is buzz.common.fa. The name of the FA is FA. The attributes of FA, well, it's public, abstract, sealed, before filled in it. Base type of FA is system.object. So I'm not inheriting it from any other class. I'm directly making it from object inside .NET. And now this is the interesting one. Qualified name of FA is buzz.common.fa, comma, common, comma, version, culture, public key token. Okay, cool. Now, if I go back, and here, let's say, I don't have the FA as the type. So we say var t equals to reflection utils dot get type, and I know that my class is called FA. Just that, okay? And now I just type T here because it returns a type, so I'm happy with it. So if everything works, I could use, come on, Nelson, and unit tests. But why bothering? So I changed the whole thing to use my reflection. If everything works, I should still get the same result. Type of FA is private implementation details, blah. Namespace of FA, new. Assembly of FA, I, C# code, and refactor. Well, it's not what I want. What's going on? Remember that in my, not here, get type method that I'm sending in just a name, I'm using first or default. The very first time it hits something that has FA, it returns it. And if I come back, let's see, where is that thing? Here we go. Look at this. It is a GUID here that contains BFA. Because it has FA, well, it fails. That is why I'm asking for a namespace. Well, my namespace, I'm not sure, but I know something. All my projects are happening under Buzz namespace. So let's build it again. Coming back and run my, let you close, and run my test now. Now we get this whole thing. Buzz.command.fa, buzz.command, blah, 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 blah. We get the result. Although I was not sure, for example here, I'm not sure what is exactly the namespace of this guy, buzz.command. I know that it is sitting under the Buzz namespace. And it happily found it for me. And the whole result is the same. So that is why reflection is so powerful. Because it says, okay, if the assembly qualify, if the, here, for example, if the thing that I'm looking at doesn't have Buzz, go on. I don't want this one. I want something that has Buzz in it. Obviously, if I add another typo here, Buzz with 3Z, the whole thing will fail. So test, and I get null reference exception because I didn't find any type here. Okay, so for example, I could say if t equals to null, then do two things for me. Debug.log warning to make it sure that it is obvious. Did not find type, correct name and namespace, and then return, so that I don't get that null point exception. So it's really important that whenever you are using reflection, you check if it's null or not. If you remember in my where is that graph utility, I'm doing it here. Not that, sorry, graphic utility. This is sort of reflection because I'm looking at assembly. Whenever you see assembly, you are doing reflection stuff. And I'm getting the executing assembly. Inside that, I'm getting the manifest resource. Right there, I'm checking if it's null or not. Okay? So wherever you are doing reflection stuff, it's up to you to check for being null or not. Okay? So if I come back, now if I clear and say test, I get a warning. Did not find the type, correct name and namespace. So that's a very cool way of, handling your stuff when you don't have access directly to your classes and methods and stuff like that. Okay, so I would say 0.1 start.1 and string.format that for example here the first one is Buzz. Of course you wouldn't do this way, but you know, just in case. That's an example. I would say class name, namespace, and then namespace and class name, whatever. But you get the idea. The reflection is a very powerful way of handling everything for you, to the point of returning the type, and then inside the type, namespaces, assemblies, full names, names, attributes, that, and everything. For example, I could get how about this, members, get members, okay? And I would say, ready for a very big debug system. So we say var members equals t.getMembers, okay? Then I say for each inside my members, member info, and I will say member, I would say member, and I will say, for example, member dot, and here is what I can get out of the member info, for example, the name of the member, okay? And if I build it now, and I really need a bigger console here now, because this will be big. No, I meant this one. Where was it? No. Wow. What was the short key to make these guys bigger? Alt? No. No. Whatever. Make it please bigger. Like this. And let's run it. Buzz test. And oh, yeah. I hit the return here. Okay? Delete. So, well, remove this part because we know it's working. Build solution. Going back to Unity. Clear and Buzz test. And here we go. So by accessing my member info, now I get access to everything inside that class. For example, get font. Well, if you look, this is an interesting stuff to talk about. And I don't have a time, but if you look, I don't have any member here that is called get font, you know. If I go back to Unity, it calls get_font. And I let you search as much as you want. There is nothing called get font. But here I have a property with the get method. This is how system behaves behind the scene. Whenever you see get underline something, it means that this something is a property with a getter. If it has a setter, then you would see get.underline_font, set_underline_font, blah blah. Equals, get hash, get type, and toString. These four come from any object-oriented script inside .NET. Okay? Now we have font and the rest of the members that we have. Okay? So all of these are those constant strings that I have there. All of them. And you see that I can look through every one of them and do whatever I want. For example, instead of, name, I could get the declaring type, or a member type, or metadata token, or module, or reflected type, okay, or get type, by the way. And that's it. Let's see the declaration type. It's interesting. So build, and please clear the console and run it. So you see that I have 595 buzz.com and FA coming out. Why is that? Well, because all of them are declared inside FA. But if I use the get, let's see, dot member type, okay? Now I see property, one property, and 593 fields. If I go and say that, hey, get type, run it, I will see that I have system.reflection.mono field, system.reflection mono property, and 5 methods there. Okay, and that's not what I want actually. So member dot yes, the class object that was used to obtain this instance of member info. And that's it. Well, there is something, I think it's the reflected type. One of them is will return system dot, string for me. I want to find that one. And no, it's returning the class itself. Oh God, member dot. Oh yeah, because I'm getting the members. Derp dot get fields. If I get fields, now, of course, these need to be changed into fields, and this needs to be field info. Although you notice that it will work because field come on, what is that? Member info yet? No, field info. Where did I? Come on. Field info is part of a member info, so that was why I didn't get any error there. So I should get info dot field type. I was looking at the members. Members are totally different than fields. And now if I run it, I will only get the fields. So I won't get that font property anymore. But I see that 593 of them are system.string. Okay? So if I go, for example, instead of fields, I get the properties. And it's property info, so I will have to change it to property info. And property info has different things now. Can read, can write. And then property type. And get type, get set method, get method, and get value, and set value. So for example, I know that my font doesn't have a setter. So if I use can write, I should get a single false at the start, at the end of these here. Okay? So let's try it. Come on. Clear? Test and false. So it says that I found a property, and that one property that I found has no setter. If I used can read, it would be true. True. So that is how reflection works. When you get, as I said, when you get the type of a class, that's the heart of reflection. From there, you can do whatever you want with that. You can get all the members of that. Remember, members means that every field, every property, and every method. That's all members. If you want the fields, then you go for the fields. If you don't want the properties, you go for the properties. If you want the methods, well, guess what? You had seen me using get fields, get properties. I have get methods, and I could use it. And this returns method info. Now, with capital M. Now, if you look, in first look, my FR class has no method, isn't it? Well, get ready for a surprise if you didn't pay attention. Oh yeah. So, because I'm using method info, now I can use return type, for example. Okay? So I can see what types are returned by a method. So, get ready for a surprise. Hey, I found a method. I found another method. I found another method. I found another method. I found another method. What are these? Well, let's declare them a bit more. If I say plus info dot name plus that, then we could why are you okay? Then we can see what is each method. Although I know what they are, but here we go. Get font. So, as I said before, any property that has a get or set in backstage, this will be converted to a method, and it returns a font. Okay. So its get font returns Unity engine.font. Then it has equals method, get hashcode method, get type method, toString method. These always come from system.object. Equals returns a boolean, get hashcode returns an int 32, get type returns a type, toString returns a string. So as you see, reflection is really looking like a magic. The only thing I knew in this menu was name of a class and part of the namespace. It could be even part of the class name. For example, if I say I have the menu, okay? I don't know the whole name of this. Here it is, buzz menu, okay? Or worse, I have creation. Here is it, graph creation pop-up. I just know I have something that has creation and it is sitting somewhere on namespace buzz. Let's run it. And you see, I still get node graph editor window graph creation pop-up. And then namespace is this, assembly is this, full name is this, name of the class is this, attributes are that, base type is editor window, qualified name is that, here are the methods, and you see that tons of methods are there that we are not using. They are some parts coming from editor window, some parts are coming from Unity, blah, 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 blah. Get max size, auto repaint, show tab, focus, show utility, show pop-up, show as drop down, show X window, close, repaint, blah, 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 blah. Okay? So here is an example of a property that has both get and set, and it's hide flags. Okay? And set returns void. And that is reflection for you guys. I can do whatever I want with whatever I want, just if I can find it inside types. And I don't need even all the types there. Part of that would be more than enough. Even if now I send creation alone, because I think nothing in Mono or .NET use creation, I should be getting the same thing. Let's see if I get the same thing. Yeah. Node graph, graph creation pop-up. So if you even don't know the namespace, but the name of the class was so unique that no other person ever used it, or at least it's not in your project, then you could even get out without using the namespace. Okay? But most people, most developers of Unity assets, especially those that contain codes, and the codes are in DLL, give you some sort of documentation about their API. One of the most important things in that API is this, the namespaces. And the reason they put it out there is for this, that if anyone wants to do anything with their API that they didn't give the direct access, if the guy is professional enough, he would be able to use reflection there. Okay? So this is our reflection utility, looking at reflection in a nutshell and see how it works. Now we know that we can get members, and members contains methods, properties, and fields. We can get properties, and on properties we can check if they have getter, if they have setter. We can get the value. If they can get the value, we can set the value if they can set the value. On fields, we can get the type they declared by. We can get the value again. We can set the value again. On methods, we can get the return type. We can get the name of the method and many other things. On the whole member system, we can get the class out of a member. And lots of other stuff actually. So the type of the member, so if it's property or a field or a method, basically when you get access to the type in memory, then you have everything in your hand. And when I'm talking about type in memory, is that each one of these classes are a type, basically. Okay, but they have an instance in memory when you are adding them in runtime, being it editor, being it game time. Now, when I'm using type of or my reflection utility, I'm getting that instance in memory. I'm not directly tweaking this code on the project, DLL. No, the DLL will be untouched. But the copy of this class, for example, in memory, yeah, I can tweak it whatever I want. The only things that I won't be able to change, for example, for constants are their values. Or for the members, their return type. I can't change it. I can't change the name of the method. But there are many more advanced stuff in system.reflection that I'm not going there right now. For example, injecting code at runtime. And honestly, I'm not sure if it will work later on when IL2 CPP becomes a thing in Unity. But the least you can do is invoking your methods, sending in the parameters to an unknown method that you just know that accepts something. Lots of things that you can do, and some of them we will look in near future, some of them we will look in far future. But I hope the concept, the base concept of reflection was more obvious to you now. Understanding the reflection is a bit hard at the start. You may need to watch this video 2 or 3 times. But when you understood the ground foundation of reflection, then you can do tons of things with it. Just be aware, reflection is not as cheap as direct assignment. And I will talk about an example here that we have, in this case, in next episode, okay? And I will say what is the difference between using reflection and direct assignment and how we can avoid reflection, although I will go with reflection in this case, but because it's in editor solution actually, GraphUtils. Yeah, it's inside the editor, so I am happy I will use reflection, but there is ways to avoid reflection if you go smart, if you go out of the box. But sometimes it's not there and you need to use reflection. Anyway, I hope this video helped some people out there, and I hope these few methods on reflection util comes handy for you guys in future. Until next episode, have fun everyone. Bye bye.